Hello, welcome back. In the last video, I promised you to proceed to more complex system configurations. And before we do that, in a minute, I will just introduce you to some more symbols in the application bar up here. We have gotten to know the first four of them, and now we go on with that one here. That is a download symbol that allows you to download the system configuration that you have currently in the browser, which is rather simple, in your local download folder. That is of utmost importance if you have made changes in the configuration via the editor, and these changes you would like to persist for future use. So let's press on it, and what you get here is a download in JSON form, and I give you just a quick idea of how that looks. So we have here the download file, and that is basically what you have seen in the editor, but now in JSON form. You can also write these configuration in JSON form and upload them, but you need to be careful to follow the right structure and syntax. So it's certainly easier as a beginner to use the editor. Now, what else have we got? We have this button here, which downloads the events that occurred during the simulation here. If you run here 200 iterations, then you will find the associated events, what went on in the system in this log here. And I just push it and download a CSV file. So here we go. I open it. Excel comes up, and then you see that you have here a whole log of what's going on. There's a timestamp, there's the work item, there's an event, value chain and process step, and eventually a worker. So we see here, for instance, that at time 95, the work item 121 was worked on in the process step 1 in the value chain alpha, and it was Sally who did the work. So this is granular atomic information, and you can feed that in any analytical tool of your liking to derive further analytical insight of the performance of the system. Now let's go back and see what else we got. I would like to skip that one here, but let's move on to this one here. This shows you the system event, or actually the application events of the lonely-lobster application, and it is showing the last event that took place. So it was, we downloaded the statistical events from the front end. So it went well, so it's green. And before that, we have loaded a configuration, or we downloaded it, and so on and so forth. And you see in reverse order, in descending order, you see what happened in the application. If something goes wrong, it will show you here. If you hide that again, you will see the last event always here in the application bar. So there's one symbol remaining. That's that one here. That's a trash can. And if you press on this button, it will drop the configuration from the front end. So all is gone. We are thrown back to the front page, the home page. And from there, we can now load, as I promised, a more complex configuration. Let's take that one here, more advanced .json, and let's have a look into it. Here in the editor, we see it's called more advanced, and we have two value chains, alpha and beta. And there are two process steps defined, and there is only one. What you see here, by the way, is that you have additional parameters provided, one of which is value degradation. What that basically says is the longer it takes to go through the value chain, the further it is degrading in value. And that means it's discounted by 10% of its remaining value every time unit it takes longer than norm effort. So the longer it takes to go through the value chain, the less valuable it is to the customer. Or in other words, the customer is not willing to pay its normal price. It will take, or he will take, or she will take it only if it's heavily discounted. So the longer it takes to go through the value chain, the less value you are generating. And that's getting a problem if you are not well organized in your value chain. This one here, injection throughput and probability, we have seen already. So we inject one item per unit into alpha, and the probability that whatever has been stacked up as new incoming word orders is injected into the first value chain or into the first process step only with a likelihood of 0.6. So it will be rather uneven. There will be sometimes 1, 0, or 2 or 3 new work items coming in, and the overall throughput still will be around 1. Then we have 2 process steps, and we have put VIP limits to it. That is also new. A VIP limit says there cannot be more than 2 work items in this process steps. No work order will be accepted or taken into the value chain unless the VIP limit, the work in progress limit, the number of unfinished work items is below or equal to is below 2, and here it is 3. Using VIP limits, work in progress limits, is a very well established form or measure to make sure that the value chains are not overloaded. So beta, similar, it has another degradation function. It says in the case that it takes longer than 2 additional time units above minimal cycle time, which is in that case 2, then it loses all its value. So it keeps its value of 3 for cycle times of 2, 3, and 4, but then when it's 5, it loses all its value. No injection throughput or probabilities are defined here, so the standard values 1 and 1 are applied. And then you have Sally, Rusty, and Vicky here. And I will show you something new that we have not yet spoken about. Every worker can make a decision which work item he or she is working on in the next time unit. And the random way of choosing that, if you have more than one unfinished work item on your table, is random. That's the normal way of doing it, or the default way of doing it, I gotta say. But you can also define other strategies. And the way how global defined work item selection strategies, or in short, strategies, are defined is as follows. You can define a strategy by giving it a name. Let's call it clever, for instance. And then you say, okay, if there are multiple unfinished work items on the table of her or his table, then look into the value, into the work item, and see what the contribution of the value chain is in which the work item is. So let's, in other words, in that case, where we have maximum here, choose the work items that have the highest added value or the highest contribution of all value chains. But you might end up with multiple work items there, because let's assume you have 2 work value chains and they have just different contribution margins. And you have 10 unfinished work items on your table because you are assigned 2 process steps in both of the value chains. Then it might well be that you end up with more than one unfinished work item of the value chain that has the higher contribution. So then you might make a further selection amongst those by remaining effort in the value chain. So you, in that case where you choose minimum here, you say from all the work items that have the highest contribution, select the one that has the least remaining effort in the value chain. So that will be finished pretty quickly. So that's the strategy how Clever works. And Magic works differently. Magic says, give me the value, add the value, not the contribution, but the value of the value chain, and take the maximum. If the worker is overloaded and assigned to multiple value chains, then it might well be that in that case, he ends up with still a couple of selected work items. And then if no further sort vector is defined, then always random is applied from the remaining work items that qualified. Okay, now let's look at Sally. Sally has a strategy. She's assigned magic. So magic is that one here, and she has only one strategy. It's magic. Then Rusty has two strategies, clever and random. That is amazing. Why is that amazing? Because you would have thought certainly the worker is following one strategy, but no, you can assign multiple strategies, and we will learn in a minute why this is interesting. And also, Vicky has two strategies assigned, namely clever and magic. And before we go into the details here, we will flip over and move on to the simulation itself. And then I will show you a little bit why this is important to have multiple, or what the reason could be that someone has multiple strategies assigned and what we can do with it. So bear with me. I will be back in a minute, and then we will simulate that very configuration that we saw here.